Hello, welcome back to Linear Algebra at AOU, course code M132, chapter 2. In this tutorial, we will look at section 2.2, which is titled Linear Combinations. Let's look at some definitions first. A vector x in Rn is a linear combination of the vectors x1, x2, etc. to xk in Rn if there exists scalars, real values c1, c2, etc. to ck that belongs to R such that x can be written as c1 times x1 plus c2 times x2 plus c3 times x3, etc. to ck times xk. Example, the vector x in R3, which has three components, 2 minus 3, 4, is a linear combination of the vectors x1, x2, and x3. How? Since x can be written as such. X is 2 times x1 minus 3 times x2 plus 4 times x3. In other words, c1 is 2, c2 is minus 3, and c3 is 4. Example, determine whether the vector x in R2, which has element 5, 0, is a linear combination of the vectors x1 equal to 1, 2 and x2 equal to 3 minus 4. In order to answer this question, we will assume that x can be written as a linear combination here with these scalar values c1 and c2. In other words, x is equal to c1 times x1 plus c2 times x2. Once we get these two values, if they exist, it means that the vector can be written. Otherwise, if these two values cannot exist, therefore x cannot be written as a linear combination of x1 and x2. Let's expand and substitute. X is equal to 5, 0 equal to c1 times 1, 2 plus c2 times x2, which is 3 minus 4. Multiplying, we have 5, 0 is equal to c1 plus 2c2 here plus 3c2 minus 4c2. This creates a system, a 2 by 2 system, whereby the variables are c1 and c2. We know how to solve this by creating the augmented matrix, the corresponding augmented matrix as 1, 3, 2, minus 4, 5, 0. Then we do the elimination process. R2 minus R1 in R2 will give us 0, minus 10, minus 10. Then we divide R2 by minus 10 to obtain 0, 1, 1. Then we do the row operations R1 minus 3 R2 in R1 to obtain 1, 0, 2. Therefore, C1 is equal to 2 and C2 is equal to 1. And hence, x is equal to 2x1 plus x2. Another example, which is a vector in R3. Determine whether the vector x equal to minus 5, 11, minus 7 is a linear combination of the vectors x1, x2, and x3. Again, we will do the same thing as before. Assume that x is equal to c1 x1 plus c2 x2 plus c3 x3. Therefore, minus 5, 11, minus 7 is equal to c1 times x1 plus c2 times x2 plus c3 times x3. If we multiply as we did before, we will get a system of 3 by 3 system where the variables are c1, c2, and c3. If we eliminate, do the elimination process, we obtain the last augmented matrix as seen here: 1, 0, 2, minus 5, 0, 1, 4 over 5, 1 over 5, 0, 0, 0. This last row here shows that the system has no solution. is impossible. Therefore, x is not a linear combination of x1, x2, and x3. This ends this tutorial.